Since the day of their conception billions of years ago, all planets in the solar system have been subject to a similar bombardment of meteorites as our planet Earth has been. As such, many worlds, and especially the inner terrestrial worlds, bear the scars and reminders of a tumultuous past etched across their surface. But these intriguing cosmic landmarks are also waiting to be explored. This is Unveiled, and today we're investigating 4 unexplained craters on solar system planets. Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content. Formed after an impact on a planetary surface, almost every surface crater shares the same basic components. They all have a floor at the bottom, surrounding walls, an upper rim atop those walls, and a scrawl of displaced material all around the site known as ejecta. Yet, despite these shared components, every impact site, like a fingerprint, is unique, and astronomers occasionally come across some that defy explanation. Our first mysterious impact formation is found on the sulfur-rich surface of Mercury. Like Earth's moon, Mercury has no atmosphere and therefore can't repair its collision sites. This means that the various impact craters picked up throughout the planet's 4.5 billion year history are near perfectly preserved. However, out of the many hundreds of recorded cavities on Mercury's surface, the crater Apollodundrus makes our list as one of the most mysterious, thanks to the enigmatic trough formation that surrounds it, known as the Pantheon Fossae. When NASA's Messenger spacecraft made its first flyby of Mercury on January 14, 2008, it discovered a whole series of new craters within the wider Caloris Basin. Among this new crop of collision scars, they discovered Apollodorus, a 25-mile-wide crater positioned in the center of a wider landform, a bizarre series of long creeping troughs projecting outwards, now known as the Pantheon Fossae. It quickly became one of the most unique crater formations in the solar system and was affectionately nicknamed the Spider, due to its visual resemblance to the Earth-bound arachnid. Despite Apollodorus's position in the center of the Pantheon Fossae formation, however, not everyone believes that the two landforms were formed by the same impact event. The more common suggestion is that this curious corner of Mercury could be the result of 2 impacts, with one happening on top where another had before. Another possibility is that the crater and troughs could be the result of some other planetary function that has yet to be confirmed. For now, it forever marks the surface of the closest planet to the Sun, and it remains unexplained. Like Apollodorus the Spider, today's second crater is also arguably more famous for the land fixtures that surround it. At just over 100 miles in diameter, Isabella is the second largest impact site on Venus. But what sets it apart more than anything else are the 2 extensive flow-like structures that span to the south and southeast of it. Venus is of course known for its volcanoes, and these flows might look like leftovers from past eruptions, but scientists don't generally believe that this is the case. Instead, there are 2 alternative theories. The first is that they're caused by a process called impact melt, which is where, thanks to the planet's thick atmosphere and high surface temperatures, plus the thermal energy of the impact itself, large pieces of rock melt upon impact to become free-flowing lava. The second theory is similar, but instead involves the release of hot gas clouds after an impact that may have caused rock to melt and form the bizarre ridges south of Isabella that way. Whatever the cause, similar flow structures can be found in and around several craters on the Venusian surface. It's just that none are quite as prominent as those seen around Isabella. In fact, due to its high temperature, high pressure, and generally hellish conditions, Venus's craters all tend to differ in composition from impact sites found on other planets. For example, since the atmosphere is so thick on Venus, most meteorites break up before impacting the planet itself, and those that do break through usually hit in clusters rather than via one big collision. The release of ejected debris is also typically more contained on Venus and less spread out. This means that large deposits form closer to the crater itself, along with the flow-like structures as seen on Isabella. There's something else that makes these stranger than most craters in the solar system, though: their apparent age. According to some studies, the craters on Venus are all relatively young, with the Venusian surface, craters included, today estimated to be only about 500 million years old. The flow formations around Isabella, then, have emerged quite recently, cosmologically speaking. And when we look at Venus, we're looking at a truly unique environment in the solar system. But now let's skip over Earth and onto our third crater, which brings us to the next stop in the planetary line, finding itself stretched across the surface of Mars. With an area of around 240 miles by 85 miles, this impact site is definitely huge, and it's known as Orcus Patera. More than its size, however, Orcus Patera is an oddity amongst craters due to its oblong shape. Unlike other large craters on Mars that maintain the standard circular condition, with debris flung out quite predictably in all directions, Orcus Patera offers an unpredictable shape. Its rim rises more than a mile above the surrounding plains, too, and its floor plummets as far as 1,800 feet below the surface. Located between two volcanoes, Olympus Mons and Elysium Mons, this abnormal landform was initially believed to be the result of volcanism itself. However, contemporary scientists no longer think this to be the case, and alternative theories have developed to suggest that Orcus Patera is, in fact, the result of an impact. The first theory is that Orcus Patera was at one point a regular round impact crater, but that over time, planetary compressional forces may have caused it to stretch out and shift into the irregular shape we see today. Another and more widely supported theory suggests that the crater was caused by a rare impact where the collision struck at a tiny angle, perhaps 5 degrees or less. A collision like this may have caused the meteorite to skid along the Martian surface, digging out the uniquely shaped crater in the process. Unfortunately, we so far have no way to conclusively prove one theory or the other, and so Orcus Patera again remains unexplained. For today's final crater, it's back to where we started, on Mercury, because during the same flyby that discovered Apollodorus the spider, the messenger probe also snapped an image of two impact cavities, again inside the Caloris Basin, but this time surrounded by dark halo rings. One of these sites offered another curiosity too, due to it having an unusually shiny crater floor. While these locations have so far remained unnamed, there are two main theories to explain the dark rings that surround them. The first is called the layered cake theory, proposing that there must be a layer of unknown material lying beneath the Caloris Basin, that when struck at the right depth is revealed amongst the impact debris. And this is what we can see today bordering some of the craters on Mercury. The second theory, known as the impact glass theory, is a variation of other impact melt theories, suggesting that the crash may have melted some of Mercury's surface, causing it to reform as glass on the crater's edge. However, while either of these theories could explain the presence of the dark halos around the craters, neither of them explains the inexplicable shine on the crater's floor, which was described at the time by a messenger team member, Clark Chapman, as though like ice shining in the sun. But ultimately, Mercury's lack of atmosphere, combined with a scorching surface temperature of more than 400 degrees Celsius, should make the presence of ice here impossible. So what could have caused this seeming anomaly? For now, it's another crater story that researchers can't quite complete. As these four examples show, remnants of planetary collision sites can be found throughout the solar system, and often these sites help us to discover the ancient history of our astronomical neighbors. But there are plenty of questions that remain unanswered as well. What caused the Pantheon Fossae to stretch outwards from Mercury's Apollodorus crater? Why does Isabella on Venus have such distinct flowing structures snaking from it? What could have caused the irregular shape of Orcus Patera on Mars? And again on Mercury, what could two distinctly haloed spots mean for the planet as a whole? Because those are four unexplained craters on solar system planets. What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.